The next question is based on the Schwartz inequality and triangle inequality theorems. So let us just write down these two inequalities. We have the Schwartz inequality, the Schwartz inequality theorem says that, let us write down the equation, inequality rather. Let us write down the triangle inequality also, and then we will discuss a little bit about these inequality. The triangle inequality. So the first inequality that we have written is the Schwartz inequality. It says that the magnitude of the inner product of two vectors, so v and w are vectors, v and w are two vectors. So this is the inner product. So the magnitude of the inner product of two vectors would be less than or equal to the product of the individual magnitudes of the vectors. This is the Schwartz inequality. It deals with the magnitude of the inner product of two vectors. The next is this triangle inequality. It says that the magnitude of the sum of any two vectors is less than or equal to the sum of the magnitudes of each of the individual vectors. So this is magnitude of v, this is magnitude of w, the magnitude of two vectors, we take the sum. This sum of the individual magnitudes will be greater than or equal to the magnitude of the sum. Also, for the Schwartz inequality, we have that the product of the individual magnitudes would be greater than or equal to the magnitude of the inner product. So these are the two inequalities that we have. Now let's look at what the questions say. The question asks us to, so this is the question, exercise 1.3.3. This question asks us, when will this equality be satisfied? The next part is, does this agree with your experience with arrows? So this is the question. Let us look at the first part of the question. The first part of this question asks us, when this equality over here in this inequality, when these equality is going to be satisfied in both these inequalities. So let us see that. Now the answer is that the equality will be satisfied only when the given two vectors are parallel to each other. Parallel meaning scalar multiples of each other. So the equality will be satisfied only when the two vectors are parallel to each other or scalar multiples of each other. Now, why do we say this? Let us see if this is indeed the case. So, let us consider V is a vector which is some scalar multiples times another vector W. So, let us look at the Schwarz inequality in this case. The Schwarz inequality for this case asks us to find out the magnitude of the inner product. So, this magnitude is going to be V times AW. Sorry, I wrote the wrong thing. If V is A times W, then that means W is 1 by A times V. So, this is 1 by A times V, and this is nothing but 1 by A times this. Now let us look at the right hand side of the inequality. The right hand side asks us to find out the product of the individual magnitudes. This is nothing but this is also, if we simplify, this thing is magnitude of V squared. So this is mod of this V squared. So we see clearly in this case we have so this equality is being satisfied for this particular case when the two vectors are parallel or scalar multiples of each other. So this is for the Schwarz inequality. Let us look at the triangle inequality. So for the triangle inequality, we need to find out the magnitude of the sum. So this so we need to find out this magnitude. This is nothing but so this is nothing but 1 plus 1 by A times magnitude of V. This is the left hand side. Then the right hand side of the inequality wants us to calculate the sum of the individual magnitudes. So let us see the sum of the individual magnitudes. So again we see that this equality this inequality is being converted to an equality. For this case, we have the left hand side this, the right hand side to be this, and these are equal. So we see that again we have the equality being satisfied for this case. So we have seen that this equality will be satisfied only when the two vectors are parallel or scalar multiples of each other. So let us look at the second part of this question. It says, does this agree with your experience with arrows? Now in schools we have learned that vectors are quantities denoted by arrows having magnitude and direction. Vectors are quantities which are denoted by arrows having magnitude and direction. This is what we learn in schools. So, but over here in the concept of linear vector spaces, we saw in the very first video that vectors are quantities which are members of a linear vector space, wherein in linear vector space we have two operations. One is the addition, the another one is scalar multiplication, and these operations and these elements satisfy a certain set of 8 axioms. So such a construct is called a linear vector space, and the elements of this linear vector space are called vectors. This is a mathematical framework that we developed, that we have defined for vectors. So does this arrow thing, this arrows having magnitude and direction, does this also satisfy all these 8 axioms? Yes, indeed. That's why they are called vectors. So let us just see this triangle and Schwarz inequality with these arrows, and let us see if what we wrote over here, that equality will be satisfied only when the two vectors are parallel, whether this is indeed true for the arrows. So let us just draw a few arrows before that. So let us say we have some arrow. This is one vector. So the magnitude of this vector is being denoted by the length of the arrow, and the direction is the direction in which the arrow points. So this is one arrow of a certain magnitude and certain direction. Another arrow can be in another direction having a different magnitude. Then we could have a third vector. Sorry, let's draw it from this thing. A third vector of double the magnitude but same direction as this blue vector. So blue vector and red vector are parallel. These two vectors are parallel, but this green vector is a different direction to this blue and red vectors. We can draw another vector which is orthogonal. So this purple vector is orthogonal to blue and the red vectors. This is making 90 degrees. So this is orthogonal. So here we have a few vectors. We have drawn a few vectors, each vector having different magnitude and certain direction. So these arrows are forming a vector space, a linear vector space. And let us see if this Schwarz and triangle inequality will be satisfied. When this equality in the Schwarz and triangle inequality will be satisfied. So let us consider again. Let us say we have two arrows A and B such that A is a scalar multiple times B. So this implies B is 1 by A times A. Now let us look at the Schwarz inequality first. So Schwarz inequality wants us to find out the inner product. This dot product A dot product B. This is the inner product. So inner product is what? It is A dot 1 by A times A is 1 by A dot A 1 by A mod of A squared. The right hand side of the inequality wants us to find out mod of A times mod of B, the norm or the length or the magnitude of A times magnitude of B. This is nothing but mod of A times mod of 1 by A, which is 1 by A times mod A squared. So again we see that the equality in this, we were considering triangle inequality. So A dot B is equal to mod A times mod B. So the equality is being satisfied in the triangle inequality for such a case of parallel vectors. Then let's look at, I wrote the wrong thing. This is not triangle, this is Schwarz inequality. Now we will have the triangle inequality. So the left hand side of the triangle inequality wants us to find out the magnitude of the sum. So this is the thing, and the right hand side wants us to find out the sum of the magnitudes. The sum of the magnitudes. Again we see that equality is being satisfied. So we have the following. So we see that equality is being satisfied for parallel vectors. So equality is satisfied for parallel vectors. Parallel vectors meaning scalar multiples of each other. So we have solved this question. We have seen two inequalities, the Schwarz inequality theorem, the triangle inequality theorem, these two inequalities over here, and we have seen that in these inequalities the equality part will be satisfied only when we have two vectors which are parallel to each other. Parallel meaning scalar multiples of each other. So this solves this question.